Hello guys, what's up? I'm Engineer AK, and in this lecture we are going to find the fourth sample problem of the chapter 2 force system. So let's get started. So here in question it is said that force F1 and F2 are on the bracket as shown, right? This is a bracket and this is the forces F1 and the F2 are acting on it. Determine the projection FB on the resultant R onto a B axis. So what we have to do, that we have find a resultant, right? The resultant of these two forces, and then the projection of it on this axis, this B axis. This is A axis, and in question it is given that on B axis its projection. Like if I simply draw it here, so if I, like, this is the vector, and if I draw a parallel vector to it, similarly this vector I will draw a parallel vector to it, right? And now what I will do, that if I draw a line on diagonal, so it is the resultant R. So we have to find this, and then we have to find its projection. Like till here, till here it is 80 Newton, right? And we have to find till here, this one. So it will give me the required answer, right? So let's see. So now if we move toward the solution, so here you can see this diagram, right? And how I have made it, that I have shown you that this is that diagonal and this is the projection, and how this angle comes out to be 50 because here it is 20, right? And here it is 30, so combined it will be 50. So that's why here it is written 50. And I have told you, if this is like if there is a straight line, and if here it is a 50 angle, so obviously here will be a 50 degree as well, right? And if here it is a 50, so here it is also a 50 mean, right? Okay, so now what we have to do, that if I apply a cosine law, right, for this resultant force, if I apply a cosine law, so c square is equal to a square plus b square. It's not plus, it's minus, right? It's minus, and here it's also minus. So if I apply the cosine law, right, so here r, and in front of r there is this angle, and how much this angle will be from here till here, it is a straight line, so this angle is 180, right? I am here writing here it is 180 degree, right? And if I subtract this 50 from this 180, so I will get this angle, right, from here till here in front of r. So that comes out to be 130, right? 180 minus 50, so 130, and the rest are the same things I have written here. And then if I will take square root here, and similarly I will take square root here, so this will be cancelled out with this one, and here we will left with the 1 over 2, right? Okay, now if I plug in these values in calculator, so 80 square plus 100 square minus 2 multiply 60 or 600, no, sorry, it's not 600, it's 80, and it's 100. Okay, so 80 multiply by 100 and multiply by cos of 130, and if I take then square root of it, so it is giving me 163.35, or I can write it 163.4, right? So 163.4, and it's Newton, right? So we have find this R. Now what we have to do, that we have to find the projection. So for projection it is simple. We already know that from here till here it's 80, right? 80 Newton. Now if I consider this triangle, this one, if I take this triangle, so this 50 is with this axis, so it will be, and you can see that this line is parallel to this, right? So here it is 100 Newton actually. So if I talk about this from here to here, this distance, if I want to find, so it will be 100 cos of 50, and this will be 100 sin of 50. So here to here it is 80, and from here to here it is 100 cos of 50, right? So if I move down, so here I have written it, right? From here to here f2, and plus 100, it is 100 because this and this line is parallel, right? So it is 100 cos of 50. So if I plug in the values, so f2 is 80, right? And plus 100 cos of 50. And if I plug in this value in calculator, so 80 plus 100 cos of 50, so we get 144.3. okay, it's 27, so we can write it 3. So 144.3 Newton. So this is the answer, right? Actually this is the answer, right? This is the projection on the b-axis, that is the projection of the resultant R on the b-axis, right? So that's it for today, and see you in next video. Thanks for watching.